Hi, Algebra 2 students. Welcome to the 10.3 video. This is for Chapter 10B, which is our second week of instruction. This says, I will use the definition of probability to find both theoretical and experimental probabilities. I think you guys will like this section because it's kind of like stuff that you've definitely seen before in other math classes. So, theoretical probability of an event. When all outcomes are equally likely, the theoretical probability that an event A will occur is. So, the probability of A is equal to the number of ways A can occur over the total possible outcomes. So, the theoretical probability of an event is often simply called the probability of the event. So, let's just take a look at an example. So here we're going to look at some marbles. So it says you reach into a bag containing 4 yellow marbles. Okay, and then there's 5 green marbles and 6 blue marbles. So it says, what is the probability of choosing a blue marble? So the way we would usually write that is the probability of a blue marble. So let's think about that. We know we've got 6 blue marbles, but over the total amount of marbles. So we want to take 4 plus 5 plus 6, which gives me 15. So I'm going to put a 15 under the 6. We could continue to simplify that. 6 over 15 is equal to 2/5. Or you could take a look at what that is as a percentage. So that would be 0.4, which is 40%. Okay, so that's the first one. Let's go to the next page. So it says you have an equally likely chance of choosing an integer from 1 through 80. Find the probability of the given event. Okay, so we've got 80 numbers to choose from. Number 1 says, what's the probability an odd number is chosen? Well, 40 of them would be odd out of the 80, and that could be a half or 50%. All right, a number greater than 50 is chosen. Well, if you think about it, 51 through 80 is equal to 30 numbers. So there's 30 numbers that are greater than 50. So we could put 30 over 80 for our answer, or simplify that to 3 out of 8 chance. Okay, a perfect square is chosen. So how many perfect squares could we have here? Well, 1 squared is 1, 2 squared is 4, and if we continue that, well, 9 squared is 81. So we could only go up to 8 squared, otherwise it wouldn't be the numbers 1 through 80. So that means there are 8 numbers we could choose from that are perfect squares out of 80, which is simplified to 1/10. And then perfect cubes. Okay, well, if we think about our perfect cubes, we could only use 1 cubed through 4 cubed to stay below 80. So that means we've got a 4 out of 80 chance here that a perfect cube is chosen, and we could simplify that to be 1 over 20. Okay, so for experimental probability of an event, so very similar. This says when an experiment is performed that consists of a certain number of trials, the experimental probability of an event A is given by, so we have the number of times that the event could occur over the number of trials. So it's really similar, but just a little bit different because it's more of like an experiment versus theoretically, because we're looking at like a chart or some actual data. All right, so here, this says you spin a spinner 24 times. Okay, 24 times. So what's the probability of stopping on blue? Well, we spun the spinner 24 times and 5 of them are blue. So that means we would have a 5 out of 24 chance. And if we look at that in our calculator, that's about 0.208. Which is about 20.8%. All right, what's the probability of it stopping on a primary color? Okay, so if you didn't know your primary colors, you could Google it. But our primary colors are, one of them is blue, one of them is red and the other one would be yellow. So we have red, blue, and yellow as our primary. So the probability that we land on a primary color would be equal to, so we have to add them together, 3 plus 5 plus 3 all over the total spins. So that is equal to 11 over 24. And that's just about 0.458. So 45.8% that we land on a primary color. Okay, let's get to the last page here, the notes for today. So an experimental probability. So this says, let's read the story. Exam grades of students in a history class are shown in the bar graph. Find the probability that a randomly chosen student in this history class received a C or better. Okay, so the probability of a C or better would be equal to, all right, well, the students who got a C or better, that would be these people right here that I'm highlighting. So we want to take 8 plus 12 plus 7 over the total amount of students. So that would be 3 plus 1 plus 8 plus 12 plus 7. So that gives me 27 out of 31 students, if they're randomly chosen, would have a C or better. And that is approximately 0.871, which is equal to 87.1%. All right, so example of using permutation with probability. So now let's think back to our other chapters where we learned about permutations. So Stan, Kyle, and Eric are 3 out of the 9 members of the Student Council in South Park, Colorado. If roles are assigned randomly, what is the probability that Eric is president, Kyle is vice president, and Stan is treasurer? So we want the probability that this happens over the total amount of outcomes. So let's think about the total outcomes first, using our permutation. So order does matter here because we have president, vice president, and treasurer. So that would be 9, and then our permutation of 3. So you would want to use your calculator for that. And that's 504. So that means there's 504 total outcomes. Now, the probability that Eric is the president, Kyle is the vice president, and Stan is the treasurer. Well, that could only happen one time, right? Like there isn't another way where this happens. This just would happen once. So the probability of this happening would be 1 out of 504 chances. So if you did type that in your calculator, that's about 0.00198. All right, and the last problem here. So now we're going to look at combinations. So this one was permutations. Now let's look at combinations where order does not matter. So a jury of 12 people is selected. So remember, 12 people. And is selected from a pool of 30 people that include 12 men and 18 women. Find the probability that the jury contains at least 11 women. So let's think about at least 11 women. Let's figure out what that means. So the jury has 12 people. So we could either have 11 women and 1 man, or we could have just 12 women and no men. All right? So there are 18 women, and we could choose 11. And that means that we've got 12 men, and we would choose 1. Remember, or means plus from our last section. And we've got 18 women, and we could choose 12. And that would mean we've got 12 men, and we would choose 0. Okay. So we want to figure out what both of these are here. So then we can add them together. So in my calculator, let's see here, let's do 18 times, okay, so that gives me 381,888 plus 18, we'll choose 12 women and 12 men, and we are choosing men. So that is 18,564. So let's add those together. And that gives me 400,452. Okay, so now that's just how many ways we could have at least 11 women. But remember, we have 30 people and we want to choose 12. So we still have to figure that out. All right, and that means we've got 86,493,225 total ways that we could arrange this. So the probability for women, or at least 11 women, would be 400,452 over the total. Really big numbers there. And if you typed that into your calculator, you would get about 0.46%. Okay, so that's the end of this video, and thanks for watching.